Hey everyone, so this is section 3.8 in the book, and if we were in class, we would have this little warm-up activity. Considering we are filming these videos because of the time of the coronavirus, this is actually probably a really good exercise to talk about. So I'm just going to kind of tell you what we would have done as a warm-up activity. So for this activity, I was talking about how a rumor spreads. But perhaps now it's better to think about how a virus spreads. So I want to just kind of do a little bit of a thought exercise here with you, and we'll kind of record it together. So in class, what we would have done is we would have gone through all this first page, but we can actually just skip to the next page to kind of talk about what should have really happened. And you'll notice that I have here like a difference between in theory and in practice, because a lot of times when we do this activity, it doesn't actually work out the way that it's supposed to. However, since we're just going to talk about this together, we can just talk about in theory, and this is fine. So we'll just focus on this last column. So let's say we start with one person who has a virus, and that person encounters another person. So after that, how many people now have the virus? It goes from 1, they've now spread that virus to 2 people. So then those 2 people go out, the original person and now this new person, and they go out and they meet somebody else. And they each meet somebody else, and now they've spread the virus on. So now how many people have it? 4. 4 people will have it. Now those 4 people go out and they each meet one person. So now how many have it? So now 8 people have it. And I think you can kind of see how this is growing here. So there's a pattern here. So those 8 people go out, they meet another 8 people each, 1 person each. How many people now will have it? It'll be 16. So this is like, we can continue this pattern, right? Just going all the way down. And so this actually models the idea of what's known as exponential growth. Also is something, very sobering to think about with how the coronavirus actually spread. This is a really simplified model, actually. We're assuming that each person just meets one other person. But the reality is, right, with the way that the virus spreads, and the reason why social distancing is so important right now, is because really if you are in a group of people, so if one person is, say, around a group of 8 people, now all 8 of those people can actually get it. So we would actually have way more extreme numbers than what I even wrote here. So just something to kind of think about. So now let's talk about exponential growth. So exponential growth, this is what it looks like. This is the graph of it. And again, so far in chapter 3, I haven't required you to know how to actually make the graph. I just want you to understand the graph. In chapter 4, we're going to talk now about making graphs, but right now we're still talking about what do the graphs mean. So now let's talk about exponentials. So first things first, let's talk about the general exponential function. So general exponentials have this form. So this is kind of the key thing that you want to know with this is f of x equals a times b to the x. A and b are real numbers. A does not equal 0. B is greater than 0. So where I want to start, similar to what I was doing with quadratics, and I wanted you just to understand everything with quadratics, now I want you to understand just kind of some general things about working with exponentials. So to start, I have a few exercises here just to kind of get us warmed up. So I'm going to tell you a function, and then I want you to evaluate the function for these values. So I'll walk through the first one with you. So for this first one, I need to evaluate f of negative 2. So if I want to evaluate f of negative 2, that means that for this particular function, this is 2 to the x. So wherever I see the x, now I replace it with this negative 2. So now this becomes 2 to the negative 2. And so how do you evaluate this? So now you have to think about what you know about negative exponents, right? So first I would rewrite this like this, and then 2 squared is just going to give me 1 over 4. So there's the idea. Continuing on, so that's f of negative 2. Now I can continue on to f of 0. So now I'm going to just repeat this, except now I'm going to plug 0 in for this. So I have 2 to the 0. And people usually forget this one. Anything to the 0th power is what? It is 1. Okay, So next, we're going to evaluate f of 1. So I'm just going to replace the x with a 1 now. So this equals 2. And then finally, this will be 2 to the third. So then this will equal 8. Okay, so I'll do one more with you. So now let's do this next one. So now I've got 1/2 to the x. So we're going to do the exact same set of evaluations though. So I've got f of -2. So now this is going to be 1/2 to the -2. Now in this case, what does it mean to have the negative exponent? Well, in this case, that means I'll actually flip the fraction. So this would become 2/1. And what is 2/1? It's just 2. So this will become 2 squared. So then this equals 4. Okay, so that's f of -2. Now let's go to f of 0. So f of 0. So now I'm just going to replace the exponent with a 0. And we just talked about this. Anything to the 0 power is just 1. Then I've got f of 1. Anything to the first power is just itself. So this will equal 1/2. And then finally I've got f of 3. So 1/2 to the third. So 1 to the third is 1. 2 to the third is 8. So this becomes 1/8. So now what I want you to do is just pause the video for a moment and try these two examples. Hit play when you're ready. Okay, so now we just have to be a little bit careful with this because we have to follow the order of operations. So remember with the order of operations, so you do the exponents first. So this is 3 times 1/3 to the -2. So first I do the exponent, so this will become 3 squared. And 3 squared is 9, so maybe I'll make these as little stars just so you can see it. And then 3 times 9 is 27. Okay, so now let's do f of 0. So I'm going to replace the exponent with a 0. Again, order of operations. So first I have to evaluate this. So anything to the 0 power is 1, so now this becomes 3 times 1, so this will actually equal 3. And then I have f of 1, so this becomes 3 times 1/3 to the 1, so this will equal just 3 times 1/3, which equals 1. And then finally I've got f of 3, so this is 3 to the 1/3 to the third. So first I evaluate 1/3 to the third, so this will be 3 times 1/27. And then if you multiply those together, you get 3/27. And what is 3/27? It's 1/9. 1/9. Okay. So there's that one. So we've got one more to do. So now let's do f of -2. So this is -1 now times 3 to the -2nd. So I go through the same steps. So first I evaluate the negative exponent. So this becomes -1 times now 1/3 squared, or sorry, I should do it consistently, times 1/3 squared. So then this is -1 times 1/9, so this ultimately equals -1/9. That would be the answer there. Then I've got f of 0. So this is -1 times 3 to the 0. Anything to the 0 power is 1, so this just becomes -1 times 1, so this equals -1. Then I've got f of 1. F of 1 is -1 times 3 to the first. So this is -1 times 3, so this just equals -3. And then finally, I have, let's see, maybe I'll write it over here because I have a little more space here. F of 3, so this is -1 times 3 to the third, so that's -1 times 27, so that equals -27. Okay, so there's that one. So now let's just maybe go to the next 2 pages here. I want to talk about just the graphs of exponentials. So to understand this, I think it's important if you pause the video for a moment. So what I want you to do is just, what pattern can you see about how the graph looks? You can see it slants one way or another. Pause the video for a second. Just take a moment to notice what does it seem like dictates which way the graph kind of slopes. So what you'll notice here, these two, so these are both greater than 1. So this is the graph shape. This is really the graph shape when So we'll say, maybe we'll be just a little bit more precise. So this is the graph shape. So if you have this a times b to the x, so this is kind of the general form of an exponential. If you're wondering where did that come from, that came from all the way back up here. So I'm just using the definition right here that I highlighted. So if that thing that has the exponent on it, so this is the shape when b is greater than 1. So notice for all of these, for these two, the thing that has the exponent on it, they're both greater than 1, versus these two, these are both less than 1. So this is the graph shape when b is between 0 and 1. So the graph will go this way if this number here is less than 1, and it will go this way if it's greater than 1. So that's kind of the idea behind that. And then the other thing I wanted to do here is I just wanted to show you what happens now if I multiply those graphs by a number. So notice actually, if you compare this page to the previous one, the shape didn't actually change, right? These still go this way, these still go this way. So you might have to take a moment just to flip back and forth between the two pages to see this. But the one thing that is changing has to do with these numbers here. So notice this now is intersecting 3, and if I come up here, before it was intersecting 1. So let's see. Here on this graph, before I multiplied it by anything, it was intersecting 1. Then after I multiplied it by 2, now it's intersecting 2. So it's kind of stretching the graph in some ways, and it also changes kind of where the graph will intersect the y-axis. And again, you can see that on these other pieces too. So here I'm at 4. If you look really closely, you can see that's a 4. But here before I was at a 1. And then here this would be 1. And now I have changed to, that would be 3. So it's this consistent thing. So the number in front here is not actually doing anything in terms of the direction that the graph goes. That has to do with this number. So these numbers here, that's what dictates what the shape is like. But if you have a number kind of multiplied in front, that can kind of stretch the graph a little bit. Okay, so that actually seems like a good place to stop. So I guess I'll pause the video here, and I'll see you guys in the next one. Thanks.